modified Euler method or Cauchy or Euler Cauchy method for numerical solution of ODE differential equation. Okay, so modified Euler method. Okay, today's class for modified Euler method for numerical solution of ODE differential equation. Suppose you have a differential equation of the form dy dx equals to f of x comma y with initial condition at the point x0. At the point x0, value of y is y0. At the point xn, what is the value of y? Okay. So this is the differential equation dy dx equals to f of x comma y, and the initial condition, this is the initial condition, y at the point x0 value of y is y0, at the point xn what is the value of y? Okay, suppose this is the point x0, at that point the value of y is y0, this is the point xn, what is the value of y? First we divide this interval x0 to xn. We divide this interval x0 to xn. We divide this interval x0 to xn into n equal subinterval. Okay? So we divide it into n equal subinterval, and length of each subinterval is h. Length of each subinterval is h. Okay. So the nodes are, first node that is x0. Next node, this is x1. x1 equals to x0 plus this step length h. Next node x2, that is x2 equals to x1 plus h. And the last node xn, that is xn minus 1 plus h. So this node suppose xn minus 1 and this step length is h. So xn is xn minus 1 plus h. These are the nodes. Okay. Now for Euler method, at the point x0 y is known, that is y0. At the point x0 y is known, y0. Now at the point x1, by Euler method y1 equals to y0 plus h f of y1 equals to y0 plus h f of x0 y0. y1 equals to y0 plus h f of y0 plus h f of x0 y0. At the point x1, value of y1 equals to y0 plus h f of x0 y0. This is for Euler method. But for modified Euler method, this y1, actually the initial approximation of y1. Okay. So for modified Euler method, calculate y1 first using Euler method. That is the initial approximation of y1. So y10 is initial approximation. This is for modified Euler method. Modified Euler method. Initial approximation of y1. y10 is y0 plus h f of x0 y0. Use Euler method for finding the initial approximation of y1. Okay. Then the first approximation of y1 equals to y0 plus h by 2 f of x0 y0 plus f of x0 plus h y0 y1 0. Okay. So the first approximation of y11 equals to y0 plus h by 2 f of x0 y0 plus f of x0 plus h y10. That is the initial approximation of y1. Okay, this is the first approximation of y1. Okay, so the first approximation of y1 is y11 equals to y0 plus h by 2 f of x0 y0 plus f of x0 plus h y10. Next, the second approximation of y1, y12 is y0 plus h by 2 f of x0 y0 plus f of x0 plus h y11 y11. Okay, the second approximation of y1, that is y12 is y0 plus h by 2 f of x0 y0 plus f of x0 plus h y11. Okay, so continue this process. The suppose p plus 1 is the approximation of y1, p plus 1 is the approximation of y1. So y1 p plus 1 is y0 plus h by 2 f of x0 y0 plus f of x0 plus h y1 p. That is, so for finding the p plus 1 is the approximation of y1 is y0 plus h by 2 f of x0 y0 plus f of x0 plus h y1p. Okay, so continue this process. If y1 p plus 1 means p plus 1 is the approximation of y1, if y1 p plus 1 is approximately y1p, if y1 p plus 1 is approximately y1p, then you can stop. Okay, and that for that case, this is the actual value of y1. Okay, that is the actual value of y1. Okay, this is for y1. Next, for calculating y2, first calculate initial approximation of y2. y20 is y1 plus hf of x1 y1. This is initial approximation of y2. y20 is y2 by Euler method. By Euler method, y20 is y1 plus hf of x1 y1. So for modified Euler method, first find the initial approximation using Euler method. That is y20 equals to y1 plus hf of x1 y1. Then y21, that is the first approximation of y1. y21 equals to y1 plus h by 2 f of x1 y1 plus f of x1 plus h y2 0. So y21 is y1 plus h by 2 f of x1 y1 plus f of x1 plus h comma y20. Okay, so for p plus 1 is the approximation of y2, that is y2 p plus 1 is y1 plus h by 2 f of x1 y1 plus f of x1 plus h y1. Okay, this is the p plus 1 is the approximation of y2. Okay, continue this process. If two consecutive iterative values of y2 they are approximately equal, then you can stop, and that is the value of y2. Okay, so for general case, modified Euler, for finding the value of yi plus 1, first find initial approximation of y plus 1, that is yi plus h f of xi yi. This is by Euler method. Okay, then the iteration formula is yi plus 1 p plus 1 yi plus 1 p plus 1 is yi plus 1 p plus 1 is yi plus h by 2 yi plus h by 2 f of xi yi plus f of xi plus h yi plus 1 p. Okay, this is the iteration formula. This is by modified Euler method. Okay, yi plus 1 p plus 1 is yi plus h by 2 f of xi yi plus f of xi plus h yi plus 1 p. Okay, for this is modified Euler method. Okay, for Euler method, order of h in the error expression is 1. For modified Euler method, order of h in the error expression is 2. Okay, for Euler method, order of h in the error expression is 1. For modified Euler method, order of h in the error expression is 2. Okay, now we solve some problem using modified Euler method. Okay, right. Problem. Compute y in bracket 0.1, compute y bracket 0.1 from the differential equation dy dx equals to x plus y. From the differential equation dy dx equals to x plus y with initial condition with y bracket 0 equals to 1, with initial condition y bracket 0 equals to 1. Okay, comma correct to 4 decimal places, correct to 4 decimal places. Okay, take h equals to 0.05. Take h equals to 0.05. Okay, using modified Euler method, we have to compute y 0.1 from the differential equation dy dx equals to x plus y with initial condition y bracket 0 equals to 1, correct to 4 decimal places. We can take h equals to 0.01. So for this problem, what is f of x comma y? F of x comma y is x plus y. F of x comma y is x plus y. Okay. Now what is x0? x0 is 0. What is y0? y0 is 1. h is 0.05. xn is 0.1. Okay, so for this differential equation we compare with dy dx equals to f of x comma y with initial condition y bracket x0 equals to y0, y bracket xn. This is the question. So if of x comma y is x plus y, x0 is 0, y0 is 1, h is 0.05 and xn is 0.1. Okay, so first calculate n. N is what? N equals to xn minus x0 by h. N equals to xn minus x0 by h. So this is equals to xn minus x0 by h. So it is 0.1 minus 0 by 0.05. So it is 2. N equals to 2. Okay. So number of subinterval is 2. So this is the point x0 and n equals to 2. So xn is x2. Okay. And we are dividing into 2 equal subintervals. So this is x1. Okay. So our target is we have to find y at the point x2. At the point x0, value of y is given, that is y0. We have to calculate y at the point x2 using modified Euler method. Okay. So first calculate value of y at the point x1. Then only you can calculate the value of y at the point x2 using modified Euler method. Okay. So by first calculate initial approximation of y1. Okay. So by Euler method, y10 is initial approximation of y1, that is y0 plus h f of x0 y0. Okay. So y10 is y0 is 1 plus h is 0.05 into f of x0. F of x0 is 0, y0 is 1. Okay. So calculate y10. y10, that is initial approximation of y1. y10 is 1.1 plus 0.05 into f of x comma y, that is x plus y. So y10 is 1.05. Okay, so y10 is 1.05. Now by modified Euler method, y11, that is the first approximation of y1, is y0 plus h by 2 f of x0 y0 plus f of x0 plus h y10. Okay, y11 is y0 plus h by 2 f of x0 y0 plus f of x0 plus h y10. Okay. Now y10 is 1.05. Now y0 is 1. So y11 is y0 1. This is 0.05 by 2 plus f of x0 is 0, y0 is 1 plus f of x0 plus h. Okay, x0 is 0, h is 0.05, comma y10 is 1.05. y10 is 1.05. Okay. So this is y11 equals to 1 plus 0.05 by 2. Now f of 0, 1 is x plus y, so it is 0 plus 1 plus this is 0.05 plus 1.05. Okay, because f of x plus y, x comma y is x plus y. So just simplify y11 is 1.0525. So the first approximation of y1, that is 1.0525. Okay, this is the first approximation of y1, and y10 is 1.05. These are not equal, correct up to 4 decimal places. So you have to continue this process. So y12, next y12, second approximation of y1, that is y0 plus h by 2 f of x0 y0 plus f of x0 plus h y11. In the last step it was y10, now it is y11. Okay, so y12 is 1 plus 0.05 by 2 f of x0 is 0, y0 is 1 plus f of 0 plus 0.05 comma y11, that is 1.0525. Okay, just simplify. y12 is this is y12, that is 1.05256. 1.05256. Okay. Now see, y11 is 1.0525, y12 is 1.0526. These are not equal. Okay, correct up to 4 decimal places. Correct up to 4 decimal places, this is actually 1.0526. Correct up to 4 decimal places, this is 1.0526. Here, correct up to 4 decimal places, this is 1.0525. So these are not equal. So you have to calculate y13. Now y13 is y13 equals to y0 plus h f of x0 y0 plus f of x0 plus h y12. So y13 equals to y plus 1 plus 0.05 by 2 f of x0 f of x0 1 plus f of 0 plus 0.05 plus 1.25 y12. Now y12 is 1.0526. 1.05256. 1.05256. Okay. y12 is 1.05256. Simplify. So y13 is y13 is 1.05 this is also 1.05256 also we have y12 is 1.05256 so write y12 is equal to, this is equal to y13, this is equals to y1, that is 1.0526, right? It is 26, correct up to 4 decimal places. You can write this is 1.05256. Okay, so y12, that is y1 1.05256, because these two are equal or approximately equal, then you can stop. That is the value of y1 1.05256. Okay, so this is y1. So the value of y1 by modified Euler method is 1.05256. Now our target is to calculate y2. Okay, so now we have to find the initial approximation of y2. By Euler method, initial approximation of y20, initial approximation of y20 is what? y1 plus h f of x1 y1. Okay, so y20 is y1 is 1.05256 plus 0.05 into f of x1. What is x1? x1 is x0 plus h. x0 is 0 plus h is 0.05. So x1 is what? x1 is x0 plus h. So it is 0 plus 0.05. So it is 0.05. Okay, directly write here 0.05. Comma y1 is 1.0526. 1.05256. Okay, 1.05256. Just simplify. So y20 is 1.05256 plus 0.05 into 0.05 plus 1.05256, because f of x comma y is x plus y. So the initial approximation of y2 is 1.10, 1.107, 1.10769, 1.10769. This is the initial approximation of y2. Okay. Now the first approximation of y2 by modified Euler method, by modified Euler method, the first approximation of y2, that is y2 1 is what? y1 plus h by 2 f of x1 y1 plus f of x1 plus h y2 0. This is by modified Euler method. First approximation of y2. y2 1 is y1 plus h by 2 f of x1 y1 plus f of x1 plus h y2 0. Okay, y2 0. First approximation of y2 is f of x1 plus h plus y2 0. Okay. Now what is y1? y1 is 1.0526, 1.05256 plus 0.05 by 2 plus f of x1 y1. f of x1 is 0.05, y1 is 1.05256 plus f of x1 plus h. x1 is 0.05 plus h, that is 0.05, comma. This is x1 0.05 plus h 0.05, comma y2 0. Now y2 is 1.10769, comma 1.10769, 1.10769. Okay. So this is equals to y21, first approximation of y21 equals to 1.05256 plus 0.05 by 2. This is 0.05 plus 1.05256 plus this is 0.1 plus 1.10769. Okay, so just simplify. So the first approximation of y21 equals to 1.1032 So the first approximation of y2 is 1.1132. The initial approximation of y2 is 1.10769. These are not equal, so we have to continue this process. So the second approximation of y2 equals to y1 plus h by 2 f of x1 y1 plus f of x1 plus h y2 1. Okay. So this is equals to 1.05256 plus 0.05 by 2 f of x1 y1, that is f of 0.05 comma 1.05256 plus f of x1 plus h, that is 0.05 plus 0.05 comma y21. What is y21? y21 is 1.1132. So in place of this, just write 1.11032. So the second approximation of y2 is 1.05256 plus 0.05 by 2 f of x y, that is x plus y, plus this is 0.1 plus 1.11032. Okay, just simplify. So this is y22. This is y22 is 1.11038. These are not equal. Correct up to 4 decimal places. y22 is 1.11038. 1.11038. But y21 is 1.11032. These are not equal because y22 actually 1.11034. Correct up to 4 decimal places. Correct up to 4 decimal places. y22 is 1.11034. But correct up to 4 decimal places. y21 is 1.11032. So you have to calculate the third approximation of y2. So y23 is y1 plus h by 2 f of x1 y1 plus f of x1 plus h y22. Okay. So this is 1.05256 plus 0.05 by 2 f of x1 y1, that is 0.05 comma y1 1.05256 x1 plus h 0.05 plus 0.05 y22 is 1.1138. So here write 1.1138. Okay, so it is 1.1138. Just simplify. y2, second approximation of y2 is 1.1138. Now the third approximation, this is actually third approximation of y2. So y23 is 1.1138. This is also 1.1138. So y23 and y22, these are equal. So y23 equals to y22 equals to y2 equals to 1.1138. Okay. So this is equals to, correct up to 4 decimal places. This is 1.1104. Just write 1.1104. Just write correct to 4 decimal places. Correct to 4 decimal places. This is the value of y2. That is our ultimate target. Okay. So by modified Euler method, by modified Euler method, y 0.1, that is y2, equals to 1.11034. 1.1104. Just write in bracket correct to 4 decimal places. Correct to 4 decimal places. Okay. Now take one more problem. Okay. Take one more problem related to modified Euler method. Just write problem. Compute y 4.2 from the differential equation dy dx equals to 2 minus y square by 5x. Compute y 4.2 from the differential equation dy dx equals to 2 minus y square by 5x. Initial condition is y bracket 4 equals to 1. Initial condition is y bracket 4 equals to 1. Okay? Correct up to, so is correct up to 3 decimal places. Correct to 3 decimal place. So compute y 4.2 from this differential equation dy dx equals to 2 minus y square by 5x. Y bracket 4 equals to 1. Correct up to 3 decimal places. Okay? H is given. H equals to 0.2. H equals to 0.2. H equals to 0.2. So for this problem, f of x comma y is 2 minus y square by 5x. This is f of x comma y. Y0. This is y0. So this is x0. This is x0. That is 4. Y0 equals to 1. H equals to 0.2. H equals to 0.2. This is xn. Xn equals to 4.2. This is f of x comma y, that is 2 minus y square by 5x. x0 is 4, y0 is 1, h is 0.2, and xn is 4.2. These are data, given data. Okay? So, first calculate n. N equals to, n is xn minus x0 by h. So, it is 4.2 minus x0 is 4, h is 0.2. So it is 1. xn is 1. So this is x0 point, and xn, that is 1. n equals to 1. So it is x1. So we have to calculate y at the point x1. And number of subinterval is 1. So n is 1. Okay. So we have to calculate y at the point x1. That is y1. Now by Euler method, initial approximation of y10 is y0 plus h f of x0 y0. By Euler method, y10, that is y0 plus h f of x0 y0. So y10 is y0. y0 is 1 plus h is 0.2, h is 0.2 plus into f of x0. f of x0 is 4, y0 is 1. y0 is 1. Okay, so y10 is 1 plus 0.2 into f of 4 comma 1. f of 4 comma 1. x0 is 4 and y0 is 1. Okay. So y10 is 1 plus 0.2 into 2 minus y square. 2 minus y square by 5 into x. Okay, so y10 is y10 equals to, just simplify, this is 1.01. 1.01. Now by modified Euler method, the first approximation of y1 is y0 plus h by 2 f of x0 y0. y11 is y0 plus h by 2 f of x0 y0 plus f of x0 plus h y10 y10. y11 is y0 plus h by 2 f of x0 y0 plus f of x0 plus h y10. Okay. Now y10 is 1.01. 1.01. So put now y0 is 1. y0 is 1, but y10 is 1.01. So it is 0.2 by 2. F of x0 is 4. y0 is 1 plus 4 plus 0.2. y10. y10 is 1.01. 1.0. Just simplify. So it is 1.1. Okay. So y11 is this is y11, that is 1.009 1.00967. Okay. So y11 is 1.00967. Okay. 1.00967. See, correct up to 3 decimal. Sorry. This is correct up to. Question is correct. Solve this problem. Correct up to 3 decimal places. Here it is 1. Correct up to 3 decimal places. This is 1.01. Correct up to 3 decimal places. So see, y11 is 1.01. 1.01. Correct up to 3 decimal places. Correct to 3 decimal places. Correct. y11 is 1.01. This is correct up to 3 decimal places. It is 1.01. Now y10 is 1.01. So these are equal. Okay. Correct up to 3 decimal places. So just write y11 is equals to y10 equals to y1 equals to 1.01 in bracket correct to 3 decimal places. So we can stop here. So the value of y1 is 1.01. So the value of y1 is so y1 is 1.01. That is therefore by modified Euler method, therefore by modified Euler method, y 4.2 is 1.01 in bracket correct to 3 decimal places. Correct to 3 decimal places. Okay. So before we stop today's class, just write to homework. Okay, right. Homework. Problem 1. Compute y 0.02. Compute y 0.02 from the differential equation. dy dx equals to x square plus y. Compute y 0.02. Compute y 0.02 from the differential equation dy dx equals to x square plus y with initial condition y bracket 0 equals to 1. With initial condition y bracket 0 equals to 1. Y bracket 0 equals to 1, comma correct to 4 decimal places. Correct to 4 decimal places. Use modified Euler method. Okay. So compute y 0.02 from the differential equation dy dx equals to x square plus y with initial conditions y bracket 0 equals to 1. Correct to 4 decimal places. Take h equals to 0.01. Take h equals to 0.01. So we have to solve the differential equation dy dx equals to x square plus y at the point 0.02. taking h equals to 0.01, x0 is 0. So you can see here that m is 2. So our target is to calculate y2 using modified Euler method. Just write answer, corrected to 4 decimal places. Answer is 1.0202. Answer is 1.0202. 1.0202. Okay. So this is problem 1. Next, problem 2. Problem 2. Okay. Right. Compute y2.1. Compute y2.1 from the differential equation. dy dx equals to 1 minus y by x with initial condition y bracket 2 equals to 2. Okay, comma correct to 4 decimal places. Correct to 4 decimal places. Okay, take h equals to 0.05. Take h equals to 0.05. So you have to compute y2.1 from the differential equation. dy dx equals to 1 minus y by x with initial condition y bracket 2 equals to 2. Correct to 4 decimal places using modified Euler method. Take h equals to 0.0. Just write answer. Answer is 2.0024. 2.0024. So these are two homeworks. Solve these two problems. Okay. Next day we will start Runge-Kutta fourth order method for finding numerical solution of ODE differential equation. Okay. Thank you.